All right, the next topic that we want to talk about in coordinate geometry is perpendicular lines. So we've talked about parallel lines as a core content, but for the extended, we also need to tackle lines that are perpendicular. First of all, I think we need to make sure that we both understand what the word perpendicular means. So just as a jog, things are perpendicular when they are at 90 degrees to each other. So we want to talk about lines that are at 90 degrees to each other. So that's a right angle. So that's perpendicular. Usually the Greek symbol that we use for perpendicular is something like that. So if we say A is perpendicular to B, that's the symbol we'll use. Okay? So we've got two lines here, A and B, that are perpendicular to each other. It means that there is a right angle between the point of intersection. Right? Line A has a gradient of 2 and line B has a gradient of -0.5. Same with C and D, two perpendicular lines. One has a gradient of 3/2, one has a gradient of -2/3. So what you'll note is that if two lines are perpendicular, then the product of their gradients is -1. So if you have line A and line B and they are perpendicular, basically what we're saying is MA times MB must equal -1, right? Where MA is the gradient of A and MB is the gradient of B. Okay? That's what that means. Cool. So, M1 and M2, if you have two lines, must equal -1. If they do, then the lines are perpendicular, or if you make M1 the subject of the equation, M1 is equal to -1/M2. So, calculate, we've got an example here. Calculate the gradient of the line joining the 2 points. So again, we just want to do a visual here so that you understand. We've got 2 points. That's the x-axis. That's the y-axis. I've got a point, let's say that's 1, 2, 3. I've got a point, and then that's 1, 2, 3, 4, 5, and 6. I've got a point there, 3, 6. I've also got a point 1, -6. We can say maybe -6 is down there. I've got a point there. That's the line. What's its gradient? So the gradient M, let's say M1, is the rise over the run. So I can see that the rise is going from left to right, -6 to 3, because that's, sorry, let me write that again, 1, -6. So the rise is, it's going from -6 to 6, so the rise is 12. Rise over run. And the run, it's going from 1 to 3, is 2. So I always say it pays to do a little sketch of the 2 points so that you really can see them visually. So I see a gradient of 6. So now if the gradient of this line is 6, and we can pretend that there's going to be a parallel line, a perpendicular line, most likely doing that, so that that's a right angle, then we know that 6, which is M1, times M2 must be equal to -1. Therefore, M2 is equal to -1/6. Which makes sense. This line was quite positive and steep, so the perpendicular line must have a negative gradient, go downwards from left to right, and could be quite shallow, so that this is a right angle. So when you draw it, when in doubt, draw it out. You can really visualize what you need to know or the answer. Again, the perpendicular line also passes through the point -1/6. Calculate the equation of the line. So I know that the perpendicular line has a gradient of -1/6. So remember, the equation of a line is y is equal to mx plus c. Therefore, y is equal to -1/xc plus x, or -1/6x plus c. I know a point is -1/6. So when y is equal to 6, x is equal to -1. So I'm going to get -6 times -1 plus c, where that's x and that's the gradient. So I know that 6 is equal to 1/6 plus c. C is therefore equal to 6 minus 1/6, which you will find is 5 5/6. So y is equal to -1/6x plus, we're going to put this as an improper fraction, 35/6.